welcome to the advanced session on building a cloud-native application from scratch. I am Kavitha Radhakrishnan. I'm a senior PM on Google Cloud, working on the GCP Marketplace as well as Kubernetes applications. And I'll be speaking with Kamil Hajduczenia, who's our partner engineer, also on Google Cloud, and who helps us get our partners on board into the GCP Marketplace. And yes, I know our names are hard to pronounce. That's how advanced this session is. Thank you. Today, we will cover the ways Kubernetes applications greatly improve the developer experience for cloud-native projects. We'll be doing a very detailed demo of building an app from scratch on Anthos, our new hybrid and multi-cloud platform, and how GCP Marketplace offers open source and commercial solutions that accelerate your development. You know, when we think about cloud native, we think about cloud native technologies that help enterprises build and run scalable and secure applications in the cloud. Containers, secure mesh, microservices, declarative APIs, these all exemplify this approach. Many of our customers, including many of you here, actually think about the way they modernize their applications using containers. And so what we found is that they would start with a few containers, and then they start to scale those containers. And then when these containers scale, they turn to Kubernetes as an orchestration engine due to its ease of use, portability, and manageability. Let's start with a quick show of hands. How many of you are using container images today? OK, fantastic. And how many of you are using Kubernetes in production right now? And it could be either on-prem or in the cloud. Great. That's a great number of you. So then I'm going to assume that many of you are familiar with core resources like pods, persistent volumes, and services that help you get your workloads onto Kubernetes. And you're familiar with the workloads resources like deployments, replica sets, stateful sets, and daemon sets for you to manage your stateless and stateful workloads. But then we asked our customers for feedback as they were writing these applications. And they told us that it was really hard to manage all of these different concepts and stitch them together. And if you do manage to stitch them together, how do you know that it will work? And will it continue working, especially as the ecosystem is scaling and changing so rapidly? So we asked ourselves, what if there was a way for us to standardize how we interact with these apps without all of this complexity? And that's how Kubernetes apps were born. What we did is we worked with SIG apps in the open source community on standardizing on an application resource, which is a custom resource definition, or a CRD, that helps define the core resources and the workload resources in your Kubernetes applications. This helps us package up these resources as a single app. Packaging up as a single app has multiple advantages. We're able to provide you then with lifecycle management, debugging, monitoring, and even building out an ecosystem of apps that we know will work well together, thereby making these enterprise-ready containerized solutions. We then went one step further. We saw that customers were using Helm charts for the deployments of these applications. And so we went ahead and added a deployer in the marketplace, in the GCP Marketplace, that really helps you deploy these apps anywhere, on-prem or in the cloud. And so we've now created these Kubernetes applications. We announced the beta last year, and these are available in the GCP Marketplace. Enterprise-ready, containerized solutions with pre-built deployment templates. We also made history with this beta launch. We were the first public cloud that could support commercial Kubernetes apps in the GCP Marketplace. But today is actually a really exciting day, because I'm announcing the general availability of Kubernetes applications in the GCP Marketplace. The GCP Marketplace, for those who may not know, is an online curation, a catalog of solutions that we offer to enterprises. They can not just find and buy solutions, just like any other marketplace, but it also offers support for management and deployment of these solutions. We offer multiple features within the GCP Marketplace. One is We're one of the few public clouds that offer really popular open source solutions packaged up in the marketplace. So for instance, RabbitMQ, which we will show in the demo later on, or PostgreSQL, that is also in the demo. One Google build, so it doesn't matter what kind of solution you're using in the marketplace, whether it's SaaS or datasets or Kubernetes apps or VMs. Any enterprise that is working with the GCP Marketplace gets one single bill at the end of the day. And you as customers can just start to use, if you're a developer that's using this, you can just start to use these products within the marketplace as well. Flexible pricing. We know that developers want to be able to have the flexibility of being able to pay as you go. And so the ability for you to really be flexible with your use, but also offering subscriptions for more predictable usage. So if you want to be able to use this over a monthly or annual subscriptions, which is going to be out in beta soon. But in addition, I also want to announce some new features as part of the general availability. The first is that these apps work with Anthos, and we'll cover a little bit in more detail what this means. But it really opens up the world for these applications to be available, build once, run anywhere. So be able to be supported on hybrid as well as multi-cloud. Cloud-agnostic metering. What this means is that we actually follow the app regardless of where the app is deployed. So let's say you are deploying onto GCP or into another cloud. You will still get metering, so you can price and know that your application is being priced correctly. We also offer custom price metrics. So for instance, if you're building a CI/CD application, then maybe you want to price on, say, the number of builds or the number of deployments. But if you're now building a database-based solution, then you can customize your pricing just on storage. And so we're very flexible about offering you those features. And the last, managed updates, which is out in alpha now, one of the top asks, and so I'm going to dig into that just a little bit more. We're introducing this because our customers told us that it was really painful for us, for users to be able to create these applications and then push them out to customers, and then not having a great way to update with the feature updates, or even if you want to fix security vulnerabilities. But instead of just doing upgrades, we've also added health checks. So we do auto rollback when there's auto triggers that can really push a rollback to a version that works. And so your customers are really protected from any changes that you may not be able to control. We've also added UI and CLI support in the marketplace, so you can push these updates at any cadence that you want to. You've all seen a version of this slide at one of your sessions today, until now, but just wanted to call out why this is such an important part of the GCP Marketplace strategy. So Anthos really opens up the world for us to be building apps that you build once and run anywhere. And so for us to be able to support this in the marketplace, so we have third-party apps that are in the marketplace today that work with Anthos. And you can start to use them, and you'll see that in the demo. This vision has attracted many enterprise partners to our ecosystem. Here's just a quick look at some of those partners. You will recognize some really familiar names. You will also see some really exciting startups. But you will also see some really popular open source solutions that Google has packaged up and is making available on the marketplace as well. These are also in multiple fields. And if you take a quick look, you'll see they're across security, database, storage and machine learning, logging, monitoring, networking, and much more. So really expanding to a base that meets the needs of any enterprise. And also excited to say that many of these are available on-prem today with Anthos. A huge thank you to these partners. They've been working very closely and really hard over the last few weeks to make this moment possible. You will see some of these particular apps in the demo. Speaking of which, let me please invite Kamil up on the stage.
Hi, everyone. I'm Kamil Hajduczenia. I'm a partner engineer at Google, which practically means that I work with our awesome partners to build some cool products for GCP Marketplace. And today I'm going to show you a few tips and tricks that I use in everyday work. Kavitha, how can I actually help you today?
That's a great question. We could have built any application or used any use case, but we've picked a broad enterprise use case that covers product and finance and marketing. But you can use this to extrapolate to any use cases you might have. So before I start, let me transform myself with these glasses into a business analyst. And I'm now speaking to my app developer. So, hey, Kamil. We need to build a custom metrics collection app that collects metric streams from all over the world. And this data cannot fail. This is absolutely critical data for our business. And also remember that the US team is on GCP, but the EMEA team is on another cloud.
OK, it's a very interesting use case. So let's start with those multiple systems that want to connect to our application. We don't have full control over them. Probably some of them are going to use some special data format or custom authentication mechanisms. So we could actually start with the REST API. The REST API can be managed by an API gateway like APG, and it will allow us to easily integrate multiple systems together. You also mentioned that you want to run our application in different environments, like different clouds. So we want our application to be portable and have a scalable ecosystem. So let's start with Kubernetes. Kubernetes sounds like a great fit. It can run anywhere on the premise and on different clouds. And actually, with Anthos that you mentioned, we can take advantage of managing those different Kubernetes clusters from a single point, which is GCP. So tell me something more about those spikes in traffic.
Yes, so see, the marketing team runs campaigns and events constantly, and so sometimes they collect new customers, which can really make the data spike dramatically.
OK, so it means that our application needs to be auto-scalable to dynamically react to increasing demands that we may see. At the same time, we want to save money, and whenever the traffic goes down, we want to have an ability to scale down. You also mentioned that we don't want to lose any data.
That's right.
So whenever we are scaling or facing any spikes, we probably want to use a message broker. A message broker will actually persist the incoming requests and let the backend handle them whenever it's possible.
A message broker sounds like a great fit, but don't forget the CIO is really concerned about the data and the security of that data.
OK, I wouldn't be that much worried about security. We can use Istio. Istio will be used for increasing the security, thanks to the different configurations that we can use. At the same time, we can actually take advantage of different monitoring capabilities of Istio.
This all sounds great, but I needed this yesterday.
OK, as always. So let's try and see what we can achieve in 25 minutes.
25 minutes? That's insane. Kamil, please take it away.
OK, let's do it. So we have a bunch of technical requirements that you mentioned. So let's do a small system design. So we started with the REST API. So we have different clients that are connecting to our system through a REST API service. It must be backed up by some component that is able to handle some logic here. So we'll have a deployment for our API. By its nature, it's extremely scalable because it's stateless. So let's take advantage of that and attach a horizontal pod autoscaler that can take care of automated scaling up and down. At the same time, we know that some of the data need to be persisted.
Correct.
So we have a separate deployment that will serve as our backend. And it has its own horizontal pod autoscaler, because by its nature, it scales differently than the stateless API. So we want to take independent configuration here. At the same time, we want to have a database where we'll persist the information. We don't want any vendor lock-in. We want to have solutions that will be able to run anywhere. So in this particular case, I will take advantage of GCP Marketplace and install an application from there. Open source version of Postgres is already available. At the same time, we need to connect those two, the front end and the back end, together. And we'll do it with a message broker with RabbitMQ RabbitMQ is also available on GCP Marketplace, and let's take advantage of that. At the same time, we need to have some configuration that will be shared across those two components. So it will be something like pointing to a specific endpoint for Rabbit, for Postgres. We'll have some secrets for authentication to those systems, and this will be shared. At the same time, we want to have Istio for additional security.
Okay.
And this is our system. OK, so let's take a demo. It's going to be live, so we'll see how it works. But in the demo, we're going to show the full experience, the full journey that a developer needs to take. So we'll start with actually creating new clusters or connecting existing ones, because this is a very common situation. At the same time, we want to deploy some applications from GCP Marketplace to GKE on-prem or external cluster. We'll take a look at the code, and we'll transform it to container images at first. And after that, we'll run a Kubernetes application on our external cluster, and then we will release a new build of that application, which is also a common situation. And at the end, we'll take a look at Istio.
And you're saying you're going to do all this in 25 minutes?
Yeah.
I'm a bit skeptical.
We'll see. OK, so let's kick off the demo. Oh, yeah, let's kick off. OK, I think we are already switched to my computer, which actually shows exactly the same screen. So yeah, great. It's true. So we're back. So as I promised, we'll start from scratch. So whenever you start from scratch, you might not have any Kubernetes cluster. So what we can do, we can create a new cluster on the cloud. And GKE UI, which is the user interface for Kubernetes Engine on Google Cloud Console, is a great way to actually start. So probably some of you have already tried it. So I'm not going to spend here too much time, and we'll not wait for the cluster to be created. But let's take a look at a few options that might be useful for our production workloads.
Yes.
So first of all, I would think about using a regional cluster instead of zonal one.
OK.
Thanks to that, I will get high availability, and I will get multiple masters running for my cluster, and all of them managed by Google. Here, I can also select to have multiple node pools, perfectly adapted to whatever my application might need. So I might have a few pools, actually, in the same cluster with different sizing. But there are also advanced options that I might actually use. So let's start with such like enable master authorized networks, which will not allow external endpoints to connect to our master instances. Then we could take a look at Stackdriver integration, which is awesome because all the logs from our Kubernetes cluster and all the metrics may automatically land in Stackdriver. And by the way, in GCP Marketplace, our application, or actually most of the applications, already expose some app-specific metrics that can be collected by Stackdriver or your own Prometheus metrics system. So if you are already familiar with Prometheus, you can take advantage of that and simply integrate our apps with your server. In addition to that, we have such add-ons like Istio. With a single click, we can install Istio on the cluster. And node auto-provisioning is also very interesting because we wanted our system to be auto-scalable. So we start with the workloads, and we use horizontal pod autoscalers to actually scale up and down dynamically. But at the same time, we might think about scaling the nodes on which our cluster operates. So additional VM instances might be created automatically, or even right sizing might happen. So the size of the individual VM instances might change.
So you can really design your entire cluster right here from within this UI.
Yep.
Gotcha.
It's so powerful.
Nice.
OK, but this use case is not that very interesting, and I think everyone is waiting for connecting external clusters. And by the way, I already have one, so let's take advantage of that. I switched to my terminal because here I have some connectivity with an external cluster. Let's see if it actually works. So I will maybe get a list of nodes from that cluster. and see if we have connection. Yeah, Houston, it works.
Nice.
Great. So we have 2 nodes that are created on another cloud. We would like to connect that cluster to GKE UI and start managing that cluster here. So I have a magic comment that, that is actually coming to be available publicly very soon. And connect. Oh, where is it? It's hidden somewhere. OK. Connect. Yep, I have it. Straight here. No, not yet.
So we know this is real.
Yeah, definitely, as always. G-Cloud. Connect. And yeah, almost there, almost there.
So what you've done here is you've created a cluster on another cloud, and which many of you may already have, right? You're already running Kubernetes on clusters that are not on GCP. And what Kamil's going to show us here is you can have this running cluster that you can then use to connect either from the cluster, using your terminal, connected to GKE, or through from GKE itself.
Exactly. This is what we are going to do. As always, network works so slowly. So once again, I will take advantage of that setup that I have already prepared. And I need a bunch of variables probably here. OK, great. And now maybe connect once again. Connect. And G-Cloud at first. Alpha, G-Cloud alpha. Yes, I got it. It's back. Live demos. Always happening on stage.
Can you tell us what was happening there?
Yes, sure. So actually, at this time, I'm installing an additional agent to our Kubernetes cluster, and it will allow GKE to handle that cluster from GKE UI. So we will have live connection between those 2. Let's see. It looks like our job succeeded. So let's come back to GKE UI and refresh the list of clusters. And yeah, it's there.
Awesome.
Awesome.
So
yeah.
what you did here was using your terminal to run commands that will help you connect the cluster to GKE. Now you're able to see within GKE not just clusters that are running on GCP, but clusters that are running on other clouds.
Exactly.
Awesome.
And as you can see, the list of nodes is exactly the same as I had in my terminal just a minute ago. So let's move further with that configuration. Once we have this external cluster connected here, maybe we could actually try to deploy an application here.
Yes.
OK. So I move to the applications screen. This is a nice list of applications that are installed to my cluster. Right now, I don't have any. So let's start with deploying the very first one. I clicked on the Deploy from Marketplace button, which actually opened up the catalog of applications available for Kubernetes clusters.
So I just want to call out here is we're pretty deeply integrated from a marketplace perspective into GCP services. So you saw where Kamil didn't have to leave the GKE UI to go find the marketplace app that he wants to deploy. It happens right there in context.
Exactly. So now I'm in a configuration screen. And as you can see, I can select a cluster to which my deployment will happen. And my external cluster is already here.
Nice.
So great. Now I may select a namespace to which I will deploy that app. So I can also customize the name. It will also become the prefix for all the resources that will be created. I just changed the size to just 2 replicas to show that it is actually a cluster. But at the same time, not to spend too much time on waiting. And let's hit the deploy button. What is happening? We move to the application installation screen, and we see some progress. I think we are going to see a more detailed information. OK, yeah, it's here.
Awesome. So you
Great.
just deployed RabbitMQ, which he procured from the marketplace, onto that external cluster that he's now managing through GKE.
So you mentioned Kubernetes applications. Kubernetes applications are a great way of managing multiple resources that form a single installation, like RabbitMQ in this particular case. Like, we don't only get the list of all the resources that formed my RabbitMQ cluster, but we can also see some additional information, like here, probably a password. Like, I wouldn't check this right now. And a username. I could use it for logging in. So in the meantime, I would just take a quick look at the service, because by default it was private. And we could see one more feature that is currently offered. And let's click on the edit button. And I would actually want to change the cluster IP type of this service to load balancer. I want to make this service available publicly. So let's hit save.
The other advantage with treating, having RabbitMQ be a Kubernetes app is that UI you just saw, where we were able to pull information from the configs and be able to show you the secrets right there from within the UI, rather than you having to dig through a bunch of config files. That was made possible because of the work we've done in packaging these into a single app.
OK. And what you can see right now, we automatically integrated with a load balancer working on another cloud, and we get a public endpoint there.
That's amazing.
So let's give Rabbit a few minutes to actually finish the installation. We can see that one of the pods is already being scheduled. We want to have two. And in the meantime, we can switch the environment to on-prem. So on-prem, GKE on-prem, was announced a few months ago, and probably most of you have already heard about GKE on-prem. Have you heard about GKE on-prem? Who heard about GKE on-prem? Great, great to see that. So not many of you had probably a chance to try it out, because this is still in alpha. But we already got a lot of feedback from our customers and partners. And it's great. Like, people love it. I love it too. So actually here, I have, in another project, I have two clusters. One of them is cloud, and the second one is on-prem. And as you can see, it is presented as an external one. I can also see all the nodes. Like, if I'd like, I can click on any of them and check some details, like metrics that are related to that particular node, or all the resources that were deployed here. So this is fully managed from GKE UI, but it is working on a separate data center on-prem. So right here, we could also try to run a deployment of another application, maybe this time something from one of our partners. So Jenkins seems to be one of the most popular CI/CD pipelines already used in the market. Like, its surveys show that it's the most popular solution for open source projects. And we actually have a partner who prepared a curated enterprise version of Jenkins, like it's CloudBees. So let's see if we can deploy CloudBees solution to an on-prem cluster. So once again, I navigated to the applications screen. I selected CloudBees. I clicked the configure button. And once again, I can select a cluster to which I will deploy this application. And so, as you can see, user cluster 1 is exactly the on-prem one. It's marked as external. I can create a new namespace this time, let's say. So this will be CloudBees demo. And I can also name my application somehow, like CloudBees demo once again. Now we have the two most complicated, I think, fields in this configuration form. So in this on-prem cluster that we have, we reserved a few IP addresses that can be used for exposing a public endpoint.
Nice.
And by the way, I already know those IP addresses. Otherwise, I would have to check them out. So
and
it would.
This is needed so we can talk to those on-prem servers or clusters.
Yep, exactly. This is what we want to have. And since I'm not entirely sure if those are the correct ones, I have prepared a small note here just for myself. OK, I've got it. So here I will use that IP address. And it's exactly the same. Yeah, I remember it well. So I will select the storage name. And here I'm running the deployment. Let's see what happens. Once again, we see the progress of the installation. And something is happening. Let's see the result. Oh, so stressful, those live demos.
This is happening live.
Yep.
And so just to talk about RabbitMQ is an open source application that you deployed to a cloud that was not GCP, and now you're taking a third-party app like CloudBees and deploying it to an on-prem cluster.
Exactly. This is what is happening here. We can see some progress, like Logo showed. So maybe let's take a look what's in the detailed information. So, moment of truth. And this is CloudBees. This is a detailed information about the application. And we can see that all the resources got created.
Nice.
So let's take a quick look at the ingress here. Maybe we'll also be able to connect to that installation and see that beautiful wizard of Jenkins. If it's already running, maybe it's not yet. So then we will need to give it a minute. I think so. It is still being installed. So in the meantime, we can take a look at RabbitMQ. And let's refresh that page and see if we already have our pods running. OK, let's take a quick look here. So we navigate to the stateful set and see the Rabbit. OK. As always, live demos. So it gracefully failed, but still gracefully failed in an external cluster. So let's take a look if CloudBees is actually here. OK, almost there, I think so. Let's take a look at this pod. And the pod is already running, so we should be able to see Jenkins in just a few seconds. So we're expecting a beautiful wizard that should actually start asking me for a password that I should take from a container. And I think something is working because I got redirected to the login page. And
oh,
yes,
awesome.
Great, I can see that.
Great.
Yeah. CloudBees running on-prem. Great. So at this point, we have already fulfilled first two steps that I promised to show. So what we did, we connected an external cluster running on another cloud to GKE. And in addition to that, we also showed deploying the application to on-prem and to an external cluster. So at this point, we should actually switch to the code and transfer it into a running application. So I know that Java is a bit like old-fashioned way of building applications, but I really like it. This is why I use Java. The problem with Java is that you always get a lot of code for doing simple stuff. But I actually used Spring Boot, and Spring Boot is pretty simple to build containerized.
What is Spring Boot?
Oh, it's an application development framework that's running in Java. Okay. It's extremely popular. Like, it allows you to take advantage of many built-in configurations and integrations. So just to take a quick look at what did we do here, we had this architecture diagram that was using a deployment for an API and another deployment for the backend. So let's take a look how it looks like here. So I have two endpoints in my application. This is the REST API.
Yep.
So I have one of them to update the usage, and this is actually what our external systems will use. They will send out data here, and another one to prepare a report of usage. At the same time, we also have a component that is handling connections with RabbitMQ, and here we have listeners that are actually taking that requests coming through RabbitMQ and handling them gracefully. So what we want to do is transform those source code components into a running application. So what we will do first is we're gonna run Cloud Build. Who has heard about Cloud Build? OK, some of you have. So what we are going to do here is use the CI/CD pipeline that's built into GCP, and you can easily define a few steps that should be executed by Cloud Build. Each of them is actually running a single container. You can pass properties to that Cloud Build. Let's just take a look. Yes, it's running. So this is a running Cloud Build instance job. In the first one, I'm building the API component, and the second is building actually the backend one. After that, my container images will be published to a container registry that is also a managed service offered on Google Cloud. Okay. So I don't only have the way to build the containers, I also have a way to store them here. And by the way, I also took advantage of another service offered on Google Cloud. This is cloud source repositories. So I didn't have to care about building my own Git repository anywhere. I already had one in Google Cloud. So this is where my code lives. So let's move farther. What can we see here is that our containers are already being built. Let's show the newest logs first. I think it will take another minute or two. So in the meantime, we could take a look about the way of transforming those container images into an actual application running on Kubernetes. So let's start with the application CRD that you mentioned previously. I already have something like this here. So this is a CRD, this is a custom resource definition that was created together with the special interest group of applications in Kubernetes. And here, I defined the application name, I defined some descriptions, versions, and so on, but most important, I defined the rules for collecting different types of workloads and resources already running in Kubernetes to say that they form together an application. So this is what I have here. And it's, of course, accompanied by other manifests that I have. So the YAML file for API, I have it here. I start with a dedicated service account and follow it with the deployment, pointing to my container image and actually exposing a service with an ingress, all of those happening in regular Kubernetes manifests, but after that collected by the application. So let's run this installation. In the meantime, we could just take a very quick look at the builds. Yep, that's done. So our container images are already built. So we're gonna run the application here. So
as you do that, just want to clarify that the audience is following along. We created a container image, and now you are transforming it into a Kubernetes app by packaging it with an application resource CRD.
Yep, exactly. We'll start with actually running the kubectl command to deploy everything. So all of our manifests will be automatically installed to our Kubernetes cluster. I'm using a proxy machine because the on-prem cluster is actually located in an external data center, and that data center does not have public connectivity by default, only through those 3 IP addresses, and it's only external, it's only egress. So what I'm going to do right now is combine 2 steps. I will enrich our manifests with sidecar proxies for Istio. And at the same time, I will apply the manifests to that Kubernetes cluster that we have.
Kamil, can you say more about why we're enriching using a Istio sidecar?
Sure. So we wanted to use Istio for additional security.
Correct.
And Istio is easily taking care of all the network traffic management. How it does it is actually built on top of Envoy. So we put those additional containers of Envoy as a sidecar to each pod running our application. And thanks to that, all the network traffic is going through those proxies inside pods. This is one of the most basic Istio features. And thanks to that, Istio is going to take care of all the traffic here. So let's take a look if our application got already deployed. So I navigate to the list of applications. And yes, it's here. It's Kubernetes app. And it says that some components are still being installed. But we can take a look at what is already here. OK, we have 2 deployments. We have services, actually 1 service and an ingress. We have the config map and the secret. That's great. So let's open that ingress. It's saying that it's still being configured, but I think it might be already available. So I click on it, and I see a beautiful Swagger UI. By the way, are you already using Swagger? Could you please raise your hand? Yeah, almost everyone uses Swagger. So Swagger is a way of defining the documentation or actually the standard of your API, and it can be easily used in an API gateway like APG to transform your Swagger configuration into a running API. So I have two endpoints here. Let's see if they work. So I will start with sending a query for a report. So let's say that I want a report for the whole year. This nice Swagger UI is actually allowing me to send REST API calls to my endpoints. Yes, I have a report. So let's see if it's also running for updates. This is what our external systems will do. So I will send an update for the same resource. I will specify some date here for the last year. Let's say on the 1st of January.
We're getting very close to your 25-minute window.
OK, I know. But we're almost done.
OK.
And we're actually confirming that everything is working. Like,
which is a big part of the demo.
Don't complain that much. Come on. So let's take a look. Here, the previous report was having some huge number, but we want to actually increase it. It ends with 8. It should end with 0 after the update. Let's try it out. OK, everything went fine. So the message was scheduled to the broker. And let's see if it was actually handled. Yeah, it was.
Yes,
great.
Awesome.
OK, so we have our application working. So just one small thing that we could do, like in this report, you can see that the overview is to do. So to do is suggesting that we are not done yet. So let's make it done. So let's take a look where it might be. It might be in the broker controller, if I remember well, because this is what I did. So we want that to be done. So let's change to do to done. And now let the magic happen. And we'll commit that change. So git add, git commit, and git commit once again. And that commit will say that and send it out. OK, so I sent out a new commit to my repository. I also added a tag here.
Okay.
And now there is a piece of magic that I wanted to show you. So there is cloud build. And in that cloud build, actually 2 new builds were already triggered thanks to that commit. Why? Because I have a trigger that is saying, actually I have 2 different triggers, that both of which are saying that whenever a new change is happening to my repository and there is a new tag, it's automatically building container images. And if I'd like, I can add additional step to actually running a rolling update on my deployments. And this is a great approach, I think, to releasing new builds. Like everything that you should care about is actually the source code. And whenever you're delivering an update to your code, it should be automatically picked up by your CI/CD pipeline and delivered to different environments. Like there's no point to doing any manual work here. OK, so you say that we are running out of time, so maybe let's not wait for that update to happen. It will build out new container images, and this new release can be used in our deployments. But there is one more thing that I wanted to show you. So we wanted to have Istio here. So let's say if my Istio connection is still working. No, so I will just run a port forward to make it happen. So port forward for Kali, yeah, on port 8082.
So what are you doing here?
I'm just running a port forward, so I want to forward the port of my Istio visualization tool, Kali, from on-prem cluster to my local computer, and let's see if it's working. So almost there, or not entirely there. Might also happen. I love those live demos. Let's just establish the connection once again. And here, I'm connecting to the first proxy. After that, to a second. This security. So just a second, and another connection with port forwarding. And after that, just one more port forward. Port forward. And OK, there is already something listening. So ps aux grep forward. And kill the previous forward. And let's do it again. Port forward. Yep, something is running. Let's see. Whoa, yeah, it worked. I love it. So just one thing that I wanted to show you is this service mesh that was automatically created by Istio. So thanks to that proxy sidecars that we had in our deployments, Istio was actually able to build the whole service mesh visualization. And we also have a small addition to that. So Postgres and Istio configuration. So what I wanted to show here is basically a kind of securing your infrastructure with Istio. So, but just by defining additional service roles for accessing the specific services in our Kubernetes cluster and binding those roles to specific service accounts or users. We can define who can connect to a particular endpoint. Like in this case, we define who is able to connect to our Postgres instance.
Fantastic. So you got through.
Yeah, that's all.
Everything?
Are you satisfied?
I'm more than satisfied. What would have taken us days is just took us minutes.
Yeah.
So that's amazing. It's awesome.
Thank you.
So what we saw in the demo is the ability to connect, deploy, create, improve, and secure. And you've seen us how we could use the GKE UI and the GCP Marketplace to really light that up. So thanks, Kamil, for walking us through those very, very detailed steps. We also wanted to just wrap up here with showing you how this strategy of being able to go after hybrid and on-prem is really attracting large enterprises to use GCP Marketplace. And we're hoping that you will also be one of them very soon, if you're not already using it. We're also seeing that we're announcing these open source service partners, which you may have seen at the keynote as well. But these are really going to help us deliver really popular open source solutions to our customers through the marketplace. And we believe that this will show our deepened commitment towards open source as well. Finally, just want to announce our newest Kubernetes app solution, Palo Alto Networks, that just announced their service mesh security adapter using Istio and is available in the marketplace today. And we're very excited because this is an example of a partner that started with VMs and is sort of expanding their portfolio to cover Kubernetes apps and other types of solutions within the marketplace. We're also welcoming a number of new and updated listings. I'm calling out updated because it shows you just how engaged our partners are with the marketplace. So you can find new apps there every day, as well as new features to existing apps that you can use. You can see a list here of brand new, exciting startups, as well as very established companies. And if you've seen the power of the GCP Marketplace. If you're a partner or a developer that wants to sell on the marketplace and really increase your reach, please go to cloud.google.com/marketplace/sell, and we can talk you through about, there's an entire process on how we can get you through the marketplace and really help you expand your reach. So today, just to recap, we covered the ways Kubernetes apps can greatly improve the developer experience for cloud-native projects. We did a demo with some real-time anxiety in it of building an app from scratch on Anthos, our new hybrid and multi-cloud platform. But Kamil showed you just how easy it is to be able to go from really nothing to being able to have a fully deployed app, not just on-prem, but in not just hybrid, but in multi-cloud scenarios. And we showed you how the GCP Marketplace is integrated into your experience and supports and offers open source as well as commercial solutions that accelerate your development. 2 calls for action. One is if you haven't visited our GCP Marketplace showcase yet, please go see the demo there. And you can visit us online at cloud.google.com/Kubernetes-applications. Thank you.